The level of significance is the smallest allowable error. I put a couple of these charts around the room. Unfortunately, this one already fell down. But this is what we're looking at today. We're going to test against your p-value. And I also gave you a table. Okay. I also gave you a table that you could keep in your notebooks. And that table is good for, like, anytime we go through this, you can check how you're going to interpret your decisions. So let's walk through a couple of these. Now, if you recall that when you assume the null hypothesis is true, a p-val, a probability value, area under the curve, of a hypothesis test is the probability of obtaining a sample statistic with the value as extreme or more extreme than the one that you found determined from your sample data. We're going to test that area under your curve, and that's why we drew your graphs. We said if it was a left-tailed test, this is the p-val that we're looking for. If it's a right-tailed test, this is the p-val that we're looking for, the area under your curve. We do this two ways. We test with the test statistic, a z-score, and we test with a area under the curve that's assigned to that z-score. The nice part is sometimes they will give you the area, or when you do your test on your calculator, and we use the calculator for this mostly. It saves you the problem of finding your test statistic and looking it up on your table. So we cut right to your calculator. And when we are given a p-val, we can test that against the level of significance. Now, I want everybody doing this the same way. I want you to say p-val, level of significance. Because if you reverse those two, and you reverse the sign, then you can't use the table. You got to reverse the logic. So that you don't have to worry about it, p-val, level of significance. So we're going to take the level of significance that they give us, 0.05. This is the smallest allowable error that we can have. We're going to usually see a 0.05, a 0.01, a 0.90. If you think about it, 0.05 is left from the 0.95 confidence interval. 1 from 90, and 01 from 99. They're kind of like the opposite of this. So we take your p-val, here's your p-val, they write it with a capital P, and we're testing it. Now, the easiest way to do this is to fill in to the right with zeros how many places you have in your p-val. How many decimal positions do we have in the p-val? 4. So this has 2. Fill in 2 more. Now, drop the decimal point. What's larger, 237 or 500? So, this is less than or equal to. 237 is less than 500. Agreed? Another way, you can just pull this over and line this up. Line it up if you like. But fill in your decimals with zeros.
Less than or equal to, less than just less than.
Because we have two things. One of them has to include the equal sign. So in this case, the less than is. This is the smallest error we'll allow, and anything less than that, or we won't allow anything smaller than that. So we don't allow that one either. So less than or equal to. If this is the case, follow this decision chart. If your p-val is less than or equal to your level of significance, your decision is reject HO. This is your decision. Today we're going to work on decisions. Now, eventually, we're going to take that HO, reject HO, and we're going to follow these charts up here. So, of course, they didn't give us who was the claim, what was the HO, what was the HA. They're just asking us right now to test. So, in number 2, p-val to level of significance. Your p-val is the same as up here, 0.02. Either that or we're going to find that. Right now, they're giving it to us right now. We'll find it in a minute. We're going to test it. So, fill this with zeros.
Why do you make the fish signs when they make the egg?
It's really an A. I just make it look like a fish for some reason. It's really like a little egg. But it's I don't know. You can make it look like this.
There's a little fishy. It's a goldfish.
Yeah. It's an alpha. It's a small alpha sign. I don't really think theirs is an A. I think it's one of those little squiggles. It looks just like an A?
Pretty much.
Okay. So mine looks close enough. So, the point is, so Nick, which number's bigger, 237 or 100?
Oh, which one's bigger, 237?
237. So this is greater than. So what's your decision according to your chart?
Fail to reject.
Fail to reject what?
Fail to reject.
You have to say H-O.
Oh, please.
And this is why. If you, Damani, why would I have to say H-O?
I don't know this lesson. I didn't know the last lesson.
Well, I would suggest that you put your stuff away and that you open your book and you focus on this.
I'm already lost.
The last lesson is about to be told together into this lesson.
Oh, so yes.
I thought I did.
No, you can't say that.
Yeah, I did. I said this unit we're using all the stuff that you learned in the past, last week, and didn't understand how to use it.
You said that today?
I say that every day. Last week, every day I said, last week did I not say on Monday, we will be using all these things and you will see how it works. Today, didn't I start with, you're going to use last week's work and incorporate it into today. I might have said a different wording, but it's really the same thing.
You had to beat the breath.
I was probably just like staring at the wall or something.
Okay, now, you have to use H-O in this. Because if you fail to reject, you could fail to reject the claim. You could fail to reject the H-A. You could fail to reject the H-O. So if you just say reject and fail to reject, it is wrong. We test the H-O only. Everything we test, look at your chart. We test H-O. So you need to say reject H-O, fail to reject H-O. Okay. Oh. This is going to be a long week. Alright, so you guys test this. Try it yourself, number one. It is at the bottom of page 363. That's all we got to so far. That's all we've got to so far today.
That good or bad?
That's not good.
Alright.
Okay,
But it's not
so,
bad.
it's not bad. Test these two values. Use your p-value. They're giving you a new p-value. See your new p-value up there? Aaron, do you see it? They're giving you a p-value. They're letting you test against two levels of significances. I really hate to give you a quiz on this.
Don't do it.
I
really hate that.
Guaranteed failure.
Then let's go together and let's test. Look at what we have. We have, and write it in this order, p-val, level of significance. Your p-val that they gave you was 0.0745. Your level of significance is 0.05. Fill it with 2 zeros and drop the decimal place. Is 745 greater than, equal to, less than 500?
Yes. Greater.
Greater than. So therefore, follow your chart. If it's greater than, our decision is fail to reject H0, the no. Check again. P-val, level of significance. We didn't change the p-val. All they did was change your level of significance. Fill it with 2 zeros. Drop the decimal.
Is our p-val always going to be 4 decimals?
It's the area under your curve, so technically yes.
Yeah.
Technically yes. Is 745 greater than or less than or equal to 1,000? Less than or equal to?
Why didn't we put the zeros together?
We did. It was 10. I added the 2 zeros.
There's 7.
No. Don't change the p-val. Adjust your level of significance so that they both match. That's the easiest way to compare them. Now, this guy is, if it's less than or equal to, we follow the chart. We say reject H0.
Okay.
H0, no, HO.
And we reject it with call no, we failed.
One had to be rejected, one had to not, because 7 is in the middle of 5 and 10. Alright. Now we're going to take this one step further. We're going to look at your tail test.
Let's get it.
Okay, we're getting there. Come on. Example 2. A left tail test. The area is in the tail. That's your standard normal curve. Area is always to the left. In the right tail, how do we get the area to the right tail? If I looked up a z-score. One minus, right? And if we're using a two-tail, what we're going to do is find the left tail area and multiply it by 2. Because we have 2 chances of getting that. Left or right tail. Now, this one, they're going to give us a test statistic. We're going to look it up. So I'm on example 2.
Try it too.
No, we're just example 2 first. So we said, find the p-val. P-val is the probability under the curve, probability P, for a left tail test. Here's my left tail test.
Draw that.
Yep. Here's my z-score of negative 2.23. How do I find its p-val?
You want to
Find
go
the
to
area.
Find area under the curve. So how do I do that?
Find the
Chart.
z-score.
Find the chart, the z-score, and when you look this up, it is the area to the left. So look it up on your z-table.
You have to use that chart from like way back.
Your table 4? Yeah. Table 4. It is in your book. And I think it might even be in the cover of your book. Is it in the cover?
Breath hot in it.
No. Is it in the first page of your book?
A16.
Yeah, it's this right there.
Yo.
It's A16. Okay. So what did we find for the area under this curve?
0.0129.
Everybody get this? Looking it up in your table.
Once you get that, now
Now you have this is your p-value. So second step now we found our p-value.
Oh, alright.
Now we go back to this.
Yeah.
Now you found your p-value this
It
time.
would be
Okay.
0.0129.
And we're going to test against this one. Fill it with zeros. Is 129 greater than or less than 100? Greater than.
Breath
So
hot in
fail to
it.
reject what?
Breath hot.
HO.
Breath hot.
Okay. Everybody work on this part. Let's try it too.
So much easier now.
Remember, you're taking this one step at a time. You have a left tail test. You have a test statistic of negative 1.71. What is your p-val?
0.0436.
I got
Point zero.
0.0426.
Okay? 0.0436. Now, we found your p-val. Now, guys, come on. P-val, level of significance. What level of significance should they say? 0.05. They're going to always give us the level of significance. Set it with 2 zeros. Good. Isn't it easier now to compare them? Less than or equal to. So what's your decision?
Reject that.
Oh, sorry. Reject HO.
So I got
Okay? Good? Okay.
breath hot in it.
What's that, the money?
My calculator is doing some crazy.
Is it your calculator?
Yeah, see, that's why I don't use the calculator.
Okay. We're going to do a two-tail test. What happens if that was a right-tail test? What would I do?
Subtract it from 1.
Subtract it from 1. Okay. If you use your calculator, though, you don't have to subtract it from 1. You're going to multiply by 2. Find the p-val for a two-tail test.
Wait, what do you multiply by 2?
Okay, watch. I'm going to show you.
Okay.
And when your z-score, two-tail test, don't these z-scores have to be the same z-score? Because your area is symmetric. So, find me the area, find the left one. It's far easier. It's the one you look up in your table. So find the area to the left. What you got, Julia? Thanks. 0.0162. And now a two-tailed test says, well, you have it on this side. You also have it on this side. So we just do 2 times the area because you have 2 chances of getting this. So we take 0.0162 and we multiply it by 2. This is your area. Right? It just doubles. Now, this is the p-value that you compare to your level of significance. And again, they gave you your level of significance. Fill it with zeros. Drop the decimal. 324 is less than 500 or greater than 500. So we say less than or equal to, and what's your decision?
Reject H out.
Good. Reject H out. So a two-tailed test, symmetrical curve, one's positive, one's negative. The area under the tails are both the same. So as soon as we find the area for the left, we double it. We have 2 chances of getting that one. So try it yourself. So Dan, what'd you find for your area under your curve? No, it can't be. I'm looking for this little left-hand test.
Oh, negative?
0.05.
Okay, thank you. So what do we do with this 0.0505? Double it. Multiply it by 2. Okay, add it together, multiply it by 2. Now, we test this. This is our p-value against your level of significance. And your level of significance is 10. But watch. When I fill this with zeros, which one is bigger?
The left.
The left. So greater than, what's my decision?
Failed to reject.
Fail to reject. H out.
Yeah, I just got one.
I knew that'd come out somewhere. I knew that would come out somewhere. So when we test against the sample, you're going to use your z-square formula for our sample. This is your central limit theorem. So you are going to go back to your regular z-score and just incorporate that part into your standard deviation. Now, your sample must be random, or at least one of the following has to happen. Your population, you're told, is normally distributed, or your sample size is greater than or equal to 30. If your sample size is greater than or equal to 30, you know your population is normally distributed. We've been doing that all along. After we do that, we're going to verify that we know the population standard deviation, that your sample is random, blah, blah, blah. We're going to state your claim, just like we did before. Identify the null and the alternative. Find your level of significance. We now are going to determine your z-score. Then we're going to do just what we did, look up your area. Then we're going to test it against your p-value. We're going to make a decision, and then we're going to go to that chart and interpret your decision. It's all is tied together right now. Ready? This is in your notes, by the way. Oops, the notes that you just picked up. The notes you just picked up. I am on the first page, right here, at the bottom of the first page. This is what we're about to do. Today we're spending on p-values. Tomorrow we're spending on reject regions. Guys, why am I getting so much talking? Okay. Yeah. I'll have to just go like this if I have to do this. Okay. All right. Example 4. We're pulling this whole thing together, guys. Watch. In auto racing, a pit stop is where a racing vehicle stops for new tires, for fuels, for repairs, for other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of the race. A pit crew claims, here's your claim, that its mean pit stop time to do 4 tires and fuel is less than 13 seconds. So let's start right here. Let's write the claim. I'm not mad. So first just give me the claim. The mean is what symbol? The U. Okay, let's start like that. We're talking population. This is a population statement. So the mean is less than 13 minutes. This is the HA. Ah, and what tail is this then? A left tail. So I'm going to start like this. So therefore, what's my HO? Good. Okay, now let's keep on going. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. Assume the population standard deviation is 0.19. Now, is there enough evidence to support the claim at a level of significance of 0.01? First of all, they didn't tell me that this is normally distributed. Is that okay?
No.
Yes, because they gave me the n. Is my n greater than or equal to 30? Yes. So if the n is greater than or equal to 30, we assume it's a normal distribution. Now we can do this. Ah, so now we've got to find your z, x minus the u over the standard deviation divided by the square root of n. What's the sample mean?
12.9.
12.9 minus what's the population mean? What's in your claim?
13.
13. Isn't your claim from the population? Didn't I write this as u? Okay, over.
Wait, why is 13 for you?
That's the claim. Over the standard deviation divided by how many is in my sample? 32. So let's find your z-score. This pulls this entire thing together, guys. So what did you get for a z-score? Good. Remember we round to 2 decimal places. Good. In a minute. In a minute. Right now we're going to do the whole thing by hand first.
You're allowed.
I will show you the calculator in a minute. Okay, so now what's our next step? Look this up in your table. And what did you find for your p-val? Now we're going to find the p-val.
0.0014.
Okay, now we're going to do what? Test 0.0014 against my level of significance, 0.0100.
Yeah.
Less than or greater than? Less than or equal to? What's your decision? Reject what?
What?
Now, hold this table next to you.
Why did we reject? Yeah, reject.
Because Oliver gave that to me.
Oh, that's
Is that
A?
Okay, now listen, guys, one more second. Listen. Follow this chart. What's your claim? Is your claim HO or HA?
HA. So there is enough evidence.
If we reject H0, that means we don't want this one. That means we like this.
Yes.
There is enough evidence to support your claim that the mean hit time hit time is less than 13 seconds.
Yep.
Ta-da!
I'm on a roll.